Hey folks, so Microsoft just released the Phi-4 Multimodal model earlier today, and I spent the last 2 hours just sort of putting it through its paces, and I think it's really good. So right off the bat, the first thing to know is that it's fully multimodal on the input side. So what that means is that the same model can take in text, images, audio tokens, reason about them, and sort of generate text that's conditioned and all of that. The second important thing is that it's quite small, so it's 5.4 billion parameters, and the implication here is that it can be optimized to run really well on multiple local devices. And so in the blog post here, it talks about how it delivers highly efficient, low latency inference, all while optimizing for on-device execution and reduce computational overhead. So overall, the model can do a lot of things. So you can do text generation, image description, captioning, audio transcription, text transcription, function calling, OCR, and in this video we're going to test out all of that. So let's head over to a Jupyter notebook and sort of take a look. Okay, so here I have a Jupyter notebook that I've put together to sort of illustrate all of the core capabilities of this model. And I'll put a link to this in the description. So the first thing to know is that Phi-4 is released with a specific set of dependencies, so a specific touch, flash attention, all this stuff. So the first thing you want to do is to create a virtual environment and sort of install all these things in order. And then once we have all of that, we have a bunch of inputs, and I've written some code scaffolding just to make it just a little easier to run inference. I'm doing all of these on a local A6000 GPU, but it probably will work really well on any consumer GPU that you have. So the first function I have is just a generic interface that can take a system prompt, a content list, and it will do all of the inference. So essentially construct the prompt correctly, figure out images, audio tokens, put them in the right order, pass them through the model, and sort of give us a response. And then we have some utilities to sort of print out results, not very important. So let's head over to the first task. And so here we're just going to look at text-only conversation, and we're going to ask it a funny question: who is Victor Dibier and what is he known for? So if we run that, we can sort of look at the response. So here it says hey, Victor Dibier is a Nigerian-born American scientist. Says a lot of things, makes up all kinds of stuff. None of this is correct. This is just a reminder that models at this size, they just because of how small they are, you probably should not be using them for factual queries or factual use cases. And the right thing to do here would be to instead give it context. So in this case, what I've done is that I went to my website and I took in all of the text and I added that as context in the first message. Then I asked it, who is Victor Dibier? What is he known for? And we can look at the response. Pretty measured. It says Victor Dibier is an expert in applied machine learning, HCI. He's a researcher at Microsoft. He's here, all his papers, all of that. And all of this is all correct. I think it's sort of looked at the important tidy parts of that text. And actually the text there is actually messages, a bunch of stuff really unorganized. But the model is able to sort of look through all of that, come up with a sensible summary, which makes sense. And all of that took about 11 seconds on this particular machine. Okay, all good. We give it a win there. Next, we head over to image description. And so here I have a couple of images. And so this is an image from a blog post I wrote a while ago, and we'll see what the image looks so far like. And what we just do is that we give it as the first message in the prompt. And then we tell it what is shown in this image. And this is what the image looks like. It's just like an illustration from an article I wrote about AI fatigue. And this is actually not particularly a naturally occurring image, but let's see how the model sort of describes that. And so here it says the image depicts a man sitting on the floor with a large battery pack on his head, which kind of makes sense. Connected to a power outlet. There are various symbols and numbers floating around him, and a text that reads, your search capacity is depleted. That makes sense, a pretty decent OCR, not very hard, but all fair enough for a fairly small model, and this took about 4 seconds. Let's see. The next thing we're going to look at is another type of image. And so here, again, an abstract kind of image. Let's see how the model does. It says the image depicts a man running on a treadmill while papers labeled new model updates, which is kind of correct. New model updates, like updates, show, vomit, all of that is flying off the treadmill and onto the floor. The man appears to be in a hurry or stressed, which kind of makes sense. It's exactly in the spirit of the illustration here. I give it another pass, pretty good. The next thing would be just a little bit more challenging. And so here we take a snapshot from a website with just a bunch of text. And so this is the technical specification for a smartphone. And essentially we want the model to sort of extract all of this text. And the query here is extract all of the text from this image and render it in a neat markdown file. And this is what comes out of the model. Just a lot of text in a markdown file. So just good instruction following here. It's doing markdown. The next thing is how good is the OCR here. And this. Okay, so if we take all that markdown and we sort of paste it in a nice markdown viewer and sort of put that side by side with the original image snapshot, we can see that like the OCR is pretty good, you know. All of the details here, let's see, display type, all of that looks correct. I haven't seen any errors or any issues, so I give it a win here. The next thing is tool calling, and so the Phi-4 model has a specific format, and essentially we describe the tools, the property of the tools. We add that to the prompt. We add that to the system prompt and close that in a tool block. And then we ask a question, what is the weather like in Paris today? And the expectation is that as part of the response, it's meant to generate a tool called token. And it actually does that. And here there's a tool called block. And we do see that, you know, it calls the right function name and calls it with like reasonable looking arguments. I'm kind of really excited to test this out with a framework like Origin, and where like tool calling is a critical part of the workflow there. So some more real world examples, just for fun. I took an MKBHD video that I think about 12 minutes long. It's a review about a mobile device, and I sort of extracted some of the audio file from that. And essentially what we're going to do is that we're going to give both the audio file from that video, and we're going to give the phone a screenshot of the specs of the phone that was being reviewed in that video, and the instruction here is compare what was mentioned in the audio review with specification shown in the image and answer these questions. And here we see the spec that's given to the model, the image spec that's given to the model, and we sort of see what the model sort of comes back with. So here it says the reviewer mentions most of the key aspects as display, camera. There are no discrepancies. The reviewer is mostly impressed, which actually MKBHD really loved the repairability of the device. So all very good. About 12 seconds. Next, we also ask the model to provide a verbatim transcript of the audio, and this one's pretty interesting actually. So I took out time, I sort of looked at everything. It was perfectly correct. So we do have the original transcript that's sort of also script off of YouTube, and we can see that like the first thing is PSA, you know, the phone that you've probably never heard of. It's pretty much accurate, you know. And of course the model doesn't translate everything, mostly because of I think the setting I have here is a maximum of 1000 tokens, but really it's pretty accurate and it's quite good. And this took the longest, I think about 72 seconds. So that brings me to the end of the video right now. So far we saw that the Phi-4 Multimodal model is quite good at audio transcription, processing multimodal input, function calling, and even OCR. And it does all of that remarkably well with just about 5.6 billion parameters. And speaking of parameters, it turns out that in this release, there were two models released, the Phi-4 Multimodal model, which is 5.6 billion parameters, but also there was Phi-4 Mini, which is 3.8 billion parameters, and has very similar performance. It's just not multimodal. And so I think next I'll be trying that out, but mostly testing it out with a multi-gen framework like AutoGen. Well, thanks for listening, and I'll catch you in the next one. Take care.